Okay. Hi, I'm Vipassana Khandare, and this is my teammate.
Hello, Cameron.
And we are going to present Lab 6 demo. So in the first part, we were asked to compute the matrix multiplication and the C code for it. So right now, we just created the executable. As you can see in my WSL, the above command created the executable, which is matrix underscore CPU. Um, then I'm running the test bench. And as you can see, it instantly did 128, 256, 512, 124. But as we increase the size to 2048, it's taking a lot of time. And this is actually true. It takes quite a bit of time. It took us more than 15 minutes to get this done. But the above time taken for the above n is stored in a file, which is so we can just go nano dimes.csv, and you can see that this is the amount of time it took for n for 128 and for 256. I'll show the code for the CPU multiplication. As you can see, we basically just are iterating over nested loops and just adding it all up and putting that in our resultant matrix, and based on that we are calculating the time for it. This is the main method for main function for this. All right, that's the first part of the project. Now,
Uh,
yeah,
you want to do this? Yeah, the other parts.
yeah,
So,
yes.
screens that. Okay, and then do that. Cool. We made a difficulty with the RTX stuff, so that's why we're switching over to my computer. Uh, so it's part two of them, correct, right?
Yes.
Cool. And the command, what was the command? It was the NVCC. Was it this one's for the first one?
This is for the tilted above.
And this one should be for.
Go up a little bit.
Is it this one? No, that's a
Ye-
Kubus.
Let me pause. So this is the part two, introduction to CUDA programming.
So we're gonna NVCC, which is the compiler for the CUDA, and we're gonna run the program itself. And yeah, those are results from the CUDA code. And that would be part two. Part three is implementing it on the Google Cloud. So this requires me to log in to the cloud itself, which I think I put it somewhere. Um, I made a private key, well, technically a public key for this. So there we go. Got in, and then now we should be able to run the naive code CUDA. Um, was that the tilde, if I'm correct, right? No, that's the
That's
next
the
one.
part two, that the commands that you just ran right now.
Got it. So now, sorry, just a lot of code. There we go. This is this one.
Yep.
Oh, it wasn't that one. It was another one. Here, let me ls real quick. Uh, I think we just ran this with the tilde as well, the shared memory. Yeah, we ran this with the tilde too.
Okay.
So it should be. Sorry, there's a slight confusion, but yeah. Part three code running on cloud. Oh, was it part two? Sorry, part two on cloud. So that ran, and then you do this bench, similar results as the prior, and it runs. So part four is the shared tilde, um, which I should have the yeah matrix. So if I were to do the NBCC matrix tilde like that, I'll put it to the matrix. Runs as expected, and then I think this one had a bench command, right? If I'm correct.
Okay, that's uh that's the wrong file. Um, if you go to Zoom, I'll send the command.
Okay.
Yep,
Ah, there we go. Yep.
yeah.
So it's the GCC first, right? If I'm correct. Or no?
No, the command that I just sent in
Oh, the whole
in
thing.
Zoom.
Yeah.
Oh, not this. Wait, not even this. Wait a minute.
Cool. All right, we found the code, but do that. We'll run it. It takes forever, so we're not gonna run it. We have a previous results though, and that's it. Um, so
So
part five.
yeah, if you see that part five is the performance comparison, and what we did is instead we combined part four and part five. And if you do nano results.csv, if you open it, you will find that for instead of a vertical table, we have a horizontal table, and we have the naive GPU code, the tilted GPU code, and the one that works for a CPU. So, and we went from n being 256 to 2048.
Ooh, part six is the Kublas. This one was giving us nightmares.
Yeah, apparently it doesn't work on normal one. It took some time to figure that part out.
Yeah, it doesn't work on standard RTX code. I mean RTX cards, but it does work on the we call it cloud machine. Jimmy call it, yeah. Um, did I name it something else again? Yeah, I have the
Mm.
Kublas right there. It's a matrix
Oh,
Kublas,
okay.
and it goes to matrix Kublas without the CU. And compiles, and then what's the next step? The results to .cv results Kublas. Since we have a different naming convention, it's going to be
The boss, yeah.
and results with Kublas. And then now if I nano it, ta-da! Yeah, it's all this good stuff. I think we just added more to it. Speed of Kublas is on the right hand side. Um,
The
similar to
NAs
the
is
one.
like very, very small. Like it's going to 3 or 4 zero, like a decimal place. So because it's going so small, we just said it's like negligible.
Yeah. And part seven is the Python code.
Yep.
Do we have that in the chat? Let's see.
Yes. The right after.
Right
There
after
you
it.
go. Yep.
This one? Yeah, the one I wrote up. Cool.
Yep.
Um, throw that in there.
We might have to change. Okay, it's the same.
To the same? Okay, cool.
Okay.
And there you go.
Yep.
That's part seven, the Python implementation. We just did it for one situation because it takes forever for other situations. Yeah. So back to
Mm,
part two with the convolution. I think we did this without the VM, so this was on my computer natively.
yes.
So you could go exit, and then yeah, back on my computer, ls. And then what was the first one?
There you go. Yep.
Convolution. That one, cool.
Yes.
Standard convolution on C. Do a little bit of that.
Can you do, yep, the bench file?
The
Yes.
bench. We're like the image. Yeah.
So this is a very we have a set M, and like it's random but not exactly random. We given it a few values that it can do. The M and K are basically the dimensions for a random matrix, and basically because we know an image is a matrix of pixels, we just gave it a random M and MK, and we are assumed that that pixel makes a valid image, and using that we have found out how much time it takes. But we will show you how we did it using an actual image. We have used the edge detection. For edge detection, we have used the Sobel filter. And let's go ahead.
You want me to show the original image? Um.
Uh, yeah, Bob.
Okay.
Yep.
Bob. That's the original image. Good old SpongeBob. We converted it to a black and white, if I'm correct, right?
Yes. The PPM or the
The
PGM, both of them work.
um the PGM? No,
Yes. Though. Yep.
double Bob. Oh no, this is
Not this
converted.
one. Uh, the first one that you can see with bob.pgm.
This one?
Yeah, it won't open, but it's a bob.pgm, which is basically using a convert command. We have converted into a
Oh, that's
grayscale.
right. Yeah, I
Yes.
totally forgot. We converted it to a
Yep.
black and white, and then we filter it through. So I'll go back to the commands and just filter it through. So
Yep.
this one, right? If I'm correct.
Yep. Yes. So as you can
Yeah.
see over here, the command basically is running the executable, and the second argument is the grayscale image that it received, and then it's giving out another grayscale. And then we are going to use the convert command to convert it from a PGM to a normal image, which is there on Discord.
Oh,
Yeah.
you have it on Discord? Okay.
Oh,
I
no,
was
you
looked
can
through.
use, you know how to do it. Yeah. So you can just be like convert out underscore Sobel dot PGM. Yeah.
Now, for refresh this, it should be Bob one. There you go.
Yep.
So that's the C implementation of it. Now we're going into the CUDA.
Implementation. Yep.
Yep. So that's all the conversion. So it was this one.
Yes.
Cool. And then you do that. You do that. Put that in there. Bob PPM failed.
Oh, you might want to convert into a PNG.
Now it says oh PNG.
Yeah.
Okay, I see what you're
Yeah.
trying to say. PNG, so I'll put GPU PPM.
Oh no, you will have to use the convert command to convert the output underscore GPU PPM to a normal PNG.
Oh, okay, okay, okay.
Yeah.
So
So
this is fine then. Yeah.
yeah, so like convert
Convert Bob.pgm.
PNG load Bob. Oh,
That should
Bob.
there you go.
Okay, there you go.
Got it.
Yeah.
Yep. And then I have to convert the output.
Yeah.
The output underscore GPU dot ppm to I spelled it wrong. To Bob second dot png, right? Yep.
Yes.
A little refresh and there you go.
Yep.
Now the last one is with the Python library.
Oh, you might want to run the bench.
Yeah, just the bench. Yeah.
You missed one command.
Which one? Oh, the
The
oh yeah
bench.
yeah
Yeah.
yeah yeah yeah. Yeah, for the sorry for the CUDA bench. There you go.
And you are realizing that the more we are using CUDA, it's the quicker it is and the better the image is getting filtered, just because GPU works so much better with that.
Now we're gonna do a bench. The Python 3 comes out with the same image. I don't like do all that, so there. That's the bench for Python.
Yeah.
And I think that's all. Yeah, that's pretty
Yep.
much it.
Yep. And that's what we did. We realized that GPU works really well. It's very it's faster than what we can get from CPU. And GPU also does better filtration and quicker filtrations, because where if you saw the result, the second one is actually slightly more pronounced. So because GPU has its own graphics, it works with that. That's it. This is our lab 6. Thank you.